All right, in this podcast, we're going to talk about covalent network solids and their properties. All right, so covalent network solids are basically a crystal that is held together with covalent bonds. So if you'll just imagine that, oops, wrong thing. If you'll just imagine that this is covalent bonds that are covalently bonded to the next thing. So they're just is this big network of covalently bonded things. There are only 7 things in the world that are covalent network solids. One is carbon is diamond, carbon is graphite, and silicon. Silicon dioxide, which is like sand, glass, quartz, silicon carbide, tungsten carbide, and boron mononitride. So the properties of these are that they are the strongest things that we know of. They have the very highest melting and boiling points, and they're just very strong. They're what we use for industrial tools. They're poor conductors. Graphite is the exception to this for a reason that you don't need to know. And thermal insulators, not that you really need to know that. The things that you need to know is that they have the high melting and boiling point, and then they're just very, very rigid, very hard substances. So every property of a covalent network solid is a direct reflection of the structure. So because covalent network solids have all of these just covalently bonded atoms, covalently bonded to each other in this huge crystal, they have really high melting points because they're very hard to break apart because of all those covalent bonds. In addition to all this covalent bonding, we also have the three-dimensional network. The three-dimensional network is just really rigid and hard, and all of the bond angles are fixed. So all of the atoms are just stuck where they're supposed to be, which makes it, again, very hard to melt them and makes them very rigid and strong. Usually you see covalent network solids within the carbon group, right? So like diamond is in the carbon group. So to summarize everything that we have gone over so far, so I just wanted to give you a summary of the strengths of all of the things that we've talked about. So covalent network solid is the strongest, then ionic, then metallic, then covalent. Remember, within covalent, you have IMFs, which are hydrogen bonding, which is the strongest, and then dipole-dipole, which is the next strongest, and then the very weakest, which is those London dispersion forces. Okay, hardness is directly related to strength, and so is melting and boiling point. So the stronger something is, the more rigid, the harder it is, and the higher the melting and boiling point. So again, at the top up here, covalent network is the hardest and has the highest melting and boiling point because it's the most stuck together, right? It's hard to get it apart, so it's hard to get it to boil. These down here, covalents with the IMFs, they just have those weak little IMF interactions. So they're really easy to break apart, so they boil a lot easier. So they have a lower melting and boiling point. Vapor pressure is kind of the opposite idea because the lower the vapor pressure, the more the molecule is sticking together. It doesn't want to escape as a vapor. So covalent network is going to have the lowest vapor pressure, where covalent things that do all these IMFs is going to have the highest because it's going to escape as a vapor very easily.